guys, welcome back. So we're going to be talking today about half-life. Now you just got done doing a lab over the fictitious element pentium, in which you took 100 pennies that were face up, and every 3 seconds you would shake them and take out all of the atoms that decayed, and then leave the remaining radioactive samples in there until you had nothing left. And then the final part of your lab was for you to graph your sample. So it was going to be your radioactive decayed atoms versus your time that it took for the whole process to take place. Okay, so and that should have resembled an exponential curve, which means it should have gone like this. Okay, and that's what it means when I say an exponential curve. Now, the half-life is when radioactive isotopes decay. They do so exponentially. So that's what I was talking about in the graph that you made. It should have been an exponential curve. Okay? The rate of decay is determined through an understanding of half-life. So, half-life is the amount of time it takes for half of the atoms of an unstable isotope to decay. Okay? So, time could mean anything. It can mean seconds, it can mean days, and it can mean years. So, depending upon the radioactive sample will depend upon the time that it takes for the sample to decay half of its mass. Okay? Now, the penny lab, we use 3 seconds as our half-life. Okay? But when we do some of these other radioactive samples, we're either going to be finding the half-life or they're going to give us the half-life. Okay? So we're going to need to determine what they're asking for in that problem. So atoms with very short half-lives, days or minutes or things like that, are more unstable than those with long half-lives. So the longer time period it takes for the sample to decay in half is a more stable element. Okay? Now, this is one example of a decay curve. So this is what you should have been doing in your lab, and this is kind of how your graph should have looked when you finished. Meaning, you started out with 100 samples, okay, 100 pennies, and you decayed until you didn't have any left, right? Now, with this sample, that can take a long time. So, in our case, if you had 100 atoms, when it reached 50%, that's one half-life. So, when 100 of these samples reaches 50, that's going to be one half-life. Then, after 50, when it reached 25, that's 2 half-lives. Then from 25 to 12 and a half, that's 3 half-lives. Then from 12 and a half to 6.25%, that's going to be 4 half-lives. And then all the way down to 3.125% would have been 5 half-lives. Now, do we actually ever have 0? Well, we can't create or destroy matter. So technically, it's going to keep halving. And so you're going to get smaller and smaller and smaller pieces, okay, of what you're looking for. But yes, it's going to keep halving its sample, okay? All right, so let's try to do one of these problems, okay? The problem says that radon-222 decays with a half-life of 3.82 days. So what they're saying is it takes 3.82 days for radon-22 to decrease its sample half. So if however much of the sample I have to get automatically 50% of that sample, it's going to take me 3.82 days. Now, if an initial sample of the element contains 1,000 atoms, so we have 1,000 atoms, how long will it take for the sample to decay down to 125 atoms? Your time must always start at 0 days, okay? So, we're going to start with 1,000 atoms at 0 days, okay? So, watch how this works. So, I have 1,000 atoms, and I want to decrease in half. So I'm going to say 1,000 divided by 2 is going to leave me with 500 atoms, okay? But I'm trying to get to 125. So now I'm going to half that again, and that's going to get me to 250 atoms. Still not there. So now I'm going to half it again, and that's going to get me to 125 atoms, okay, which is where I needed to be. So how many half-lives is that exactly? Okay, so from 1,000 to 500, that's 1 half-life. From 500 to 250, that's 2 half-lives. From 250 to 125, that is 3 half-lives. So it took me 3 half-lives to get from 1,000 to 125. Now, I'm still not done yet because I'm not looking for the number of half-lives. I'm looking for the time it took to go from 1,000 to 125. So my next step is I'm going to take my half-life time, what they gave me in the problem, the 3.82 days, and I'm going to multiply that by the number of half-lives. And that's going to give me the total time for the sample to decay. All right? So let's do that. So we're going to take 3.82 days times 3 half-lives, and that's going to give us 11.46 days. So it takes, the total time it takes for radon 222 is 11.46 days. Okay? So now, in that particular problem, they were wanting us to find the total time. Now, I'm going to show you another problem in which they want to ask something completely different. So we have to do that one a little bit different, okay? So this next problem says, what if I had an initial sample of zinc 61 and it contains 215 grams? After 976 days, the sample size has reduced to 13.4375 grams. What is the half-life of zinc 61? So in this problem, we know the total time, we know how many grams we started with, and we know how many grams we had left, okay? So we're gonna have to do this one a little bit different than we did the last one. So let's see how we do that, okay? So we're gonna start out with our 215 grams, and we're gonna keep decreasing that amount in half in order for us to get all the way down to 13.4375. So you do the first one. You say, okay, at 215, I'm going to half that. That gives me 107.5. Not there yet. I'm going to half it again. That gives me 53.75. Not there yet. So I'm going to half it again. That gives me 26.875. Still not there. So I'm going to half it one more time, and that gets me to 13.4375 grams, which is where I started and ended, right, in the problem. Now, that's going to take 1 half-life there, 2 half-lives there, 3 half-lives there, and 4 half-lives. So it's going to take me a total of 4 half-lives to go from 0 or 215 to 13.4375. Now, in order to find the half-life, we're going to have to flip that problem, right? Instead of multiplying now, we're going to need to divide. We're going to take the total time divided by the number of half-lives, and that's going to tell us the half-life at each individual step, okay? So you're going to take 976 days divided by 4 half-lives, and that's going to give you 244. Okay, so zinc 61 has a half-life of 244 days. Okay, so now I've taught you 2 things. I've taught you how to find the total time when given the starting sample, the ending sample, and the half-life. Then I showed you a problem where you got the starting sample, the ending sample, and the total time, and we were looking for the half-life. Now I'm going to show you one problem a little bit different, okay? So thorium-230 decays with a half-life of 80,000 years, okay? If an initial sample has a mass of 10 grams, how much will remain after 320,000 years? Okay, so in this problem, I got the total time, I got the half-life, and I got the starting amount of grams, okay, the mass. So I need to figure out how much is left after it undergoes a half-life for 320,000 years, okay? So in this problem, I've got to start out with my times, okay, because those are the two things I'm given that were the same, all right? So what I'm going to do is I'm going to take the total time divided by the half-life time, and that will tell me the number of half-lives it's going to take for my sample to decay. All right, so I want to figure out how much remains in that amount of time. So I'm going to take 320,000 years, I'm going to divide by 80,000 years, and that's going to give me 4, which means it's 4 half-lives. That means I'm going to need to half my sample 4 times, and then whatever's left over after 4 times of halving my sample, that's how many grams will remain of the sample, okay? So let's do it. So I'm going to say 10 divided by 2 gives me 5. That's 1 half-life. Then I'm going to go 5 divided by 2 gives me 2.5. That's 2 half-lives. Then I'm going to say 2.5 divided by 1.25, excuse me, 2.5 divided by 2 gives me 1.25. That's going to be 3 half-lives. And then I'm going to take 1.25 divided by 2, and that's going to give me 0.625 grams. And that's my 4th half-life. So as you can see, I had to go through 4 half-lives, and this is how much remains. So at the bottom, I'm going to say 0.625 grams will remain after 4 half-lives, okay? Now, you guys are going to get a sheet where you're going to be working out a various number of problems. Please, if you have any questions, either refer back to the video or email me or Miss Bunch, and we will try to help you as much as we can, or do a Google Meet and answer any questions that you might have. I hope you guys have a good day.